Alright, this is my Chapter 17 reassessment. The problems are: find the electric potential at points A and B for charges positive 4.2 nanocoulombs and negative 6.4 nanocoulombs, located as shown in the figure. The second problem is: what is the potential difference, the change in V, for a trip from A to B? And the third problem is: how much work must be done by an external agent to move a point charge of positive 1.50 nanocoulombs from A to B? Alright, first thing I did was I drew our figure that was in the book. And this is our negative charge and our positive charge. So we know that the positive is the 4.2 nanocoulombs and the negative is the negative 6.4 nanocoulombs. And then I changed all the centimeters to meters on this side. So it'd be 15.9 times 10 to the negative 2 meters, 12 times 10 to the negative 2 meters, and 6 times 10 to the negative 2 meters. Okay, and then I wrote down my constant that's given to me on my formula sheet, and then my Q1 is my first charge, and I changed nanocoulombs to coulombs, so that's going to be 4.2 times 10 to the negative 9 coulombs, and I did the same thing for the second charge, so it's going to be negative 6.4 times 10 to the negative 9 coulombs. Alright, to calculate the potential difference, we use this formula right here. Okay, but we have to do it for the positive A charge and the negative A charge distance. So you have to do it 2 times for this one. So you plug in your constant, which is 9 times 10 to the 9, times 4.2 times 10 to the negative 9 divided by 6 times 10 to the negative 2. And for the positive A, you're going to get 630 volts. Okay, for your negative A distance, or electric potential difference, you're going to do the same thing, but instead of using the 4.2, you're going to use the negative 6.4 times 10 to the negative 9. And then instead of the 6 centimeters, you're going to use the 15.9 times 10 to the negative 2 meters. And you're going to get negative 362 volts. And then to get this V, you add these two together to get you the 268 volts. And that's the electric potential for A. Okay, for B, you do the same formulas as above, and then for these, you're going to use the 4.2 times 10 to the negative 9 divided by 12 times 10 to the negative 2, which is going to give you 315 volts. And then for this one, you're going to use the negative 6.4 times 10 to the negative 9, and that you're going to use the 12 times 10 to the negative 2 meters, and that's going to give you negative 480 volts. And then you do the same thing that you did up here. You add them together, and that's going to give you negative 165. Okay. Okay. The change in V, for these, you just subtract the things we just found, which is the VB and then the VA. So subtract those numbers, and you get negative 433 volts. Okay. For the last problem, for the work done, you do the charge that they gave us in the problem, which was the 1.50 nanocoulombs. So we're going to go ahead and just change that to coulombs in the problem, and then you subtract the VA and the VB again, and it's going to give you 6.495 times 10 to the negative 7 joules.